Welcome everybody to another one of James's videos. We're going to be dealing specifically with financial maths and missed payments today, or deferred payments. So the concept and the scenario we have lying around this is that you've been granted a loan and you've been making payments on your loan for the last I don't know how many months. And suddenly you run into some financial difficulties, or there's certain reasons that are allowing you not to pay your monthly installment, which means that you will miss a few payments. And then obviously once you're back on your feet and you can make your monthly installments to pay back this loan, your loan process will start again. But unfortunately, guys, the bank isn't nice. And they're not going to say to you, okay, cool, no, we understand you're running into financial difficulties. Let's pause your loan exactly where it is now, and then you can pick up once you have the funds to continue with the installments. No, it doesn't work like that. What the bank does is they'll say, cool, no problem. We'll stop your loan, but whatever you owe us at that point where you stop making your payments, we are going to charge interest on the amount that you owe us. So that when you start again, the money that you owe us is going to grow for the amount of months you miss your payments. And then you can start again. So you actually end up paying the bank more back when you missed your payments. Now, this question goes about doing this, and I've used this example because it covers that quite nicely. So let's check what we're dealing with. A couple want to buy their first house for 900,000 Rand. They agree to pay monthly installments of 9,000 Rand on a 20-year loan at 10% per annum compounded monthly. The first payment is made 1 month after the loan is granted. Now, that last little sentence there, the first payment was made 1 month after the loan was granted. In financial maths, that is considered to be a normal scenario, meaning you don't have to add 1 to your n or affect your number of months that you're dealing with. It's only when payments are made immediately do we then need to add 1 to our n value, because we're obviously including an extra month's worth of interest. But when it is made 1 payment period after the loan or the investment is being made, your n value will remain untouched. Okay, perfect. Great. So the first thing I want to look at is 1.1, show that the loan will be paid off after 216 months. Fantastic. So let's get started. So we need to work out n, right? So here we're dealing with an n calculation. So what do we got? We're going to be using the present value formula. Why? Because we are dealing with a loan, and present value annuity formulas deal with loans, and that's going to be over I. Okay, so we presently have 900,000. We're going to be making payments of 9,000 Rand per month. 1 minus 1 plus our interest rate is 10% compounded monthly to the power of minus n, which is what we're trying to solve for, all over 10% over 12. Okay, now we're going to do some algebra just to get some simplification going here. I want to get n by itself. I want to isolate the n value. So we're going to first bring up the denominator. So the 900,000 is going to times by the denominator, and we're going to divide it by the 9,000. Equals 1 minus 1 plus 10% over 12 to the minus n. If you don't know what I did there, a good idea is to maybe look at your videos on making certain things of formulas, because that was an algebra step. The next thing that we're going to do is we're going to bring the 1 over. So 900,000. Notice how I haven't used my calculator yet, eh? Very important. So 900,000 over 9,000 minus 1 equals minus 1 plus 10% over 12 to the power of minus n. Okay, everyone with me on that one? Fantastic. Now we're going to be using, or we're going to be doing the putting it into our calculator now. Okay, so when we put this into our calculator, we are now going to be working out. Let me just okay, so we are going to put 900,000. We're going to put that into our calculator. Let's put that into our calculator, and we're not going to press the on button on your calculator, guys, because that clears your memory. But if you do have one of the fancy new calculators, then apparently when you turn it off, it doesn't clear your memory. So minus 1. Okay, so that's going to give me minus 1 over 6, a nice solid fraction. Sometimes, guys, it's not so nice. Maybe it's a long decimal, but I don't want you to press the on button because you can use the ANS function on your calculator to store it. So obviously what's going to happen here is the two negatives are going to fall away. And what we can use here is our log law. So our log law is going to be log, oops, that's not a log, James, log BA equals C and B to the C equals A. So that's the formula to be using how we change exponential form into log form, which is this is the case here. So we're going to have to say a log of 1 plus 10% over 12 and of a sixth is equal to minus n. Therefore, minus n is going to equal the, where is it now? There we go. So we're going to have log of 1 plus 10 shift percent over 12 of 1 over 6. Now, guys, I'm just putting this straight into my calculator as it has a log function. 125,905 reoccurring. And the ends are going to cancel as well because we're dividing both sides by a negative. Therefore, n is equal to 215,905 reoccurring. This means that we are going to be making, so n is equal to 216 payments. But what we need to understand is that it's going to be 215 payments of 9,000. And then one payment less than 9,000. Okay, so I just need you guys to understand that. That will be on another video where we work out final payments of scenarios where our n value is a decimal and we need to work out what that final payment amount is. But that will be on another video. So we have now proven the first question. Fantastic. Let's move on to the next one, which is actually the mixed payment side of things here. So we've got 1.2. The couple encounter unexpected medical expenses and are unable to pay the 100th, 101 or 101st, 102nd payments. At the end of the 103rd, they decide to increase their monthly payments so they can still pay the loan off in 216 months, i.e. that means that there will be 114 equal monthly payments to go. Determine the value of the new monthly installments. Okay. So obviously, if you miss payments, either you can increase the amount you're going to be paying every month to match the same time period as what you had, or you can also increase, so keeps the same monthly installments, but then obviously increase the amount of time that you're paying the bank back. But in this case, they're wanting to increase the monthly installments to stick to the same amount of time that they're paying the bank back. So 1.2, if I had to timeline this, okay, so we've got that. We've got T0. We know that they're missing the 100th, 101st, and 102nd. So at T99 is when we make our last payment. They're missing T100, T101, T102, and then they're making their new payment at T103, and then their last payment at 16. So what's happening here, and I'm going to use a bit of color. What we're going to first do, guys, is we're going to first work out what our outstanding balance is after the 99th payment. So n is equal to 99. Why am I doing that? Because I want to figure out, okay, I've been good. I've paid 99 payments up until the point where I was in a bit of financial difficulty and I can't pay more. So I want to know at that 99th payment, after that, immediately after that 99th payment, how much do I still owe the bank? That would be your first step. Your second step would be your amount you owe the bank is now going to gain interest for 3 months. Okay, so that would be normal compound interest formula. Because obviously that money that you owe the bank is just going to sit there for the 3 months that you're not paying, but it's obviously going to go and gain interest. Okay, and then so that n is going to equal 3. Now the other side of it is taking what's left, and that's going to start, and that's going to be 114, but we're going to use our present value formula, and our end's going to be 114. Why? Because from 102 to 216 is 114 months, which means you still have 114 payments to go. And we're going to use the present value formula with our newfound loan value that we get from our blue step, and we're going to figure out what the installments need to be in order to still end your loan period at 216. So let's have a look. We're going to say outstanding balance. We're going to use the future value method. Okay, so that's P1 plus I to the n minus x square bracket 1 plus I to the n minus 1 all over I. Okay, so my outstanding balance, which is my red step, is going to be the loan, which is the 900,000. Open bracket 1 plus, still a 10% compounded monthly, and our end value is 99, minus x, which is 9,000, open square bracket, 1 plus 10% over 12 to the power of 99 minus 1 all over 10% over 12. Okay, so therefore my outstanding balance, let's maybe reverse that. Our outstanding balance for this question is going to be 670,663,18. Okay, fantastic. So that's our outstanding balance step. Now we're going to work out, okay, so that's, let me just highlight that in red, outstanding balance step. Now I want that outstanding balance is now going to gain interest. So that's step 1. Step 2, we're going to say A is equal to P open bracket 1 plus I to the n. So that's going to be the 670,663 Rand and 18 cents is now going to gain interest at 10% over 12 for 3 months that you're missing your payments, okay? So that's going to be a total of, that's gaining for 3 months, so that's going to be 687,569,87. Bearing in mind that whenever I get these big values, guys, I'm actually not clearing my calculator and rounding up too early. I'm using this stored value all the way through. Okay, so that is number 2 step. Now we're going to move on to number 3 step. Now, number 3 step is using my present value annuity formula with my newfound loan. Okay, so we're going to go 1 minus 1 plus I to the minus n all over I. Okay, now we're going to take that present value of 687,569,87, remembering that I'm using the A and S function in my calculator. I'm then going to say X, which is what I'm trying to figure out. I want to know what my new monthly installments are. Okay, and we're putting that in to the power of minus 114. Remember, that's our end value for this step. And then we're putting that over 10% over 12. Okay, and then we're doing a little bit of algebra here. 569,87 is going to times by my 10% over 12 all over 1 minus 1 plus 10% over 12 to the minus 114 is equal to X. Therefore, my X for my new installments will be bigger than my old ones. So let's see how much that's going to be. We have to pay in 9,366 Rand and 41 cents every month, starting from over here, starting from the 103rd month. We need to then pay that in order to make it in the same time as what our original loan was planned for. Okay, so guys, that is missed payments. Excuse that. We've got that, and we've got our payments that we need to work out. So there's a nice little color coding system there, and it is quite nicely laid out. We first needed to work out our N. We actually did a little bit of a double whammy here. Not only did we learn about missed payments, but we also got reminded on how to work out an N value with financial maths and using logs. Okay, any questions? Please feel free to message the channel, and please feel free to click subscribe if you like this video and you'd like to see more. And yeah, I look forward to seeing you guys on the next videos. Have a good one.